Since we have our unit circle now so nicely divided up into 30-degree wedges, let's just take a look at a 30-degree angle triangle. Some interesting things about it. This might not be exactly right, but whoops. Let's get rid of that one. Okay. Let's say that this is a 30-degree angle. That means this is a 60-degree angle, and here's our 90-degree angle. And I'm going to define our hypotenuse as having a length of 1. I want to know how long is that side of the triangle. And I can do that. What I'm going to do is a little bit of geometry. I'm going to flip this triangle down. And now I have duplicated it, kind of flipped it that way, so I have another 30-degree angle here. Well, that means this angle right here is 60 degrees. And I know that this angle here is 60 degrees. And that means this angle here is 60 degrees. So what I now have is an equilateral triangle. And if I have an equilateral triangle, it means not only are all the angles the same size, but all the sides are the same size. So this side right here is 1, just like my hypotenuse was. And this side right here is 1, just like my hypotenuse was. Well, since I duplicated my first triangle, that means that this side right here is 1/2 of 1. So this side here is equal to 1/2. Well, now I can calculate this remaining side. Because I know, thanks to Pythagoras, that a squared plus b squared equals c squared. And a squared I'm going to call 1/2, so I'm going to go 1/2 squared, plus b squared is my unknown side, and c squared is my hypotenuse, so that's 1 squared, that's equal to 1. Well, 1/2 squared is 1/4, plus b squared is equal to 1. Let's subtract the 4th from both sides. I have b squared is equal to 3/4. Let's take the square root of both sides, and I know that everybody in the audience is saying, square root, plus or minus, plus or minus. But we don't have to do plus or minus here because we can't have a negative distance, negative side of a triangle, so we're just going to deal with the pluses. So that is b is equal to radical 3 over radical 4, which means b is equal to radical 3 over 2. We have just found the length of this side, radical 3 over 2. Now you say radical 3 over 2 what? I don't know what, because I didn't define the unit. All I said was that the hypotenuse was of a unit 1. 1 inch. If it's 1 inch, then this one here is 1/2 inch, and this one here is radical 3 over 2 inches. Radical 3 over 2 is an irrational number, but it is still a real number, and it's acceptable. So now I've looked at this, and I said, well, I have a 30-degree triangle, 30, 60, 90-degree right triangle. And I want to bring this back a little bit to some trigonometry. So I'm going to erase this right here. Bring it back to a little bit of our trigonometric functions. Sine is equal to opposite over hypotenuse. Let's write it up here. So, TOA. Sine is equal to opposite over hypotenuse. Well, if I take sine 30 degrees, that's equal to 1/2 my side opposite over my hypotenuse is 1. So sine 30 degrees is equal to 1/2. What about cosine 30 degrees? Well, cosine 30 degrees. Let's print this here, sorry. Is equal to adjacent, radical 3 over 2 over hypotenuse, which is 1. So cosine 30 degrees is equal to radical 3 over 2. And lastly, tangent 30 degrees. We've already discovered that tangent is the same thing as sine over cosine. So let's take sine, and that's 1/2 divided by radical 3 over 2. A little bit of the algebra here, a little bit of the arithmetic. 2 over radical 3 times 2 over radical 3. That becomes 1. My 2's cancel out. I have 1 over radical 3. And because I don't want a radical in the denominator, I'm going to rationalize it by multiplying by radical 3 over radical 3, which is 1. And that gives me radical 3 over 3. So sine over cosine, as we know, is tangent. So now I have my 3 trigonometric functions for a 30, 60, 90 right triangle. I can find cosecant, secant, and cotangent simply by taking the reciprocal of those 3 functions. But now I want to take this knowledge and I want to kind of plug it back into our unit circle. So here is a unit circle, and we know that this is a 30-degree angle. We've already determined that. Well, I'm going to take this 30-degree angle in my unit circle, and I'm going to go from this spot right here, and I've already determined my radius is 1. Remember that? My radius is 1. So I'm going to drop a little perpendicular line right here so that I've made a right triangle. This is a 30, 60, 90 right triangle. I think you can see it. I'll just draw it in a little bit darker here. Now you can see that the hypotenuse of this right triangle is also a radius. And since I've defined my radius as 1, then my hypotenuse is 1. Well, if I have a 30, 60, 90 right triangle, I know that the side opposite my 30 degrees is a measure of this. So this right here is a measure of 1/2. And I know that this point right here, this distance right here, is a measure of radical 3 over 2. That has given me some very interesting information. Because I want to look at this point right here, pi over 6. Pi over 6. What is the x value of pi over 6? I'm going to turn this into an xy axis. So I'm drawing here my y-axis. I'm drawing across my x-axis. And my unit circle starts right here at the origin, 0, 0. So that point right here is 0, 0, right in the middle. The coordinates of the point pi over 6, well, my x value is radical 3 over 2. And my y value is 1/2. Those are the coordinates of my point, radicals pi, those are the coordinates of the point on my unit circle of pi over 6. Radical 3 over 2, and 1/2. And I have another 30, 60, 90 right triangle if I kind of look at this one right here. Well, let's look at it this way. I'm going to drop this perpendicular down to there. Now I know that this angle is 60 degrees. And I know that this angle is 30 degrees. Well, what do I know then? I know that this distance I've just drawn in green, because again, now I have this 30, 60, 90 right triangle. This distance I've just drawn in green is 1/2. And this distance here is radical 3/2. My x distance of this point is 1/2. And my y distance, going from bottom to top, is radical 3/2. Those are the coordinates of that point. So relating this back to trigonometry a little bit, and I'm sorry it's getting a little bit messy, but I'm hoping you can follow my colors. Let's look at this point right here, pi/6, 30, 60, 90 right triangle. I know that the sine of 30 degrees, sine of 30 degrees is equal to 1/2, right there. I know that cosine of 30 degrees is equal to radical 3/2. Well, what I am beginning to see here is that when I'm looking at a unit circle, the coordinates of my point on any spot of the unit circle is the sine or the cosine. The sine is my y value, and the cosine is my x value. This is great stuff to know. So now I know that for example, the angle pi/3, which is the same as a 60 degree angle, I can just look at the coordinates. And I can say, oh, well, cosine pi/3 is equal to 1/2. And I can say sine pi/3 is equal to radical 3/2. It makes it much easier to figure this stuff out. Now, the only thing that I'm going to change here a little bit is that, and let's actually go to another page here. So I redrew my unit circle. I put in my x and y axes. I hope you can see them okay. And I labeled a couple of points that we just did a second ago. In this quadrant here, quadrant number 1, I have positive x's and positive y's. In quadrant number 2, I have negative x's and positive y's. Quadrant number 3, I have negative x's and negative y's. And in quadrant number 4, I have positive x's and negative y's. So if I swing over here to quadrant number 2, I can see that at this point right here, well, my y value of that point, I'm going to have a 30, 60, 90 right triangle. My y value is going to be radical 3/2. And my x value, the length of my x value is going to be 1/2, but it's going to be negative 1/2 is the point. Or if I'm down here at 7 pi/6, again, I'm going to make myself a 30, 60, 90 right triangle. I can see that my y value, well, I can see that my y value at 7 pi/6 is negative 1/2. And my x value is negative radical 3/2. So we're going now from this situation here, where I was dealing with a triangle and I was only looking at the positive numbers because I was only looking at distance, to this situation here, where I put it into the unit circle, I have an x and a y axis, and now I have coordinates that are both positives and negatives, because you can have sine or cosine can be positive or negative. So, for example, sine 7 pi over 6 is equal to negative 1/2. Or let's write it here, sine 2 pi over 3 is equal to radical 3 over 2. The coordinates of the point on the unit circle, where that angle is. So to briefly summarize here, when you're working with a unit circle, I'm writing unit circle, by definition, radius equals 1. Sine is the y-coordinate. Cosine is the x